So we're here to talk through this tough TomTom no-touch puzzle by Serkan. It has a step which is fairly typical in regular TomTom puzzles to begin, and then it's going to use the no-touch rule a lot as we go along. The step that's usual to begin is if there are ever a set of cages that fully complete a row or column, you may want to focus on those and see which possible number sets can complete that. And it's not that we can exactly specify any digit in this, but we can specify the sets of digits that are going to work in these cages. For instance, in the top row, 60 has to be a multiplication. It's going to have to take a 5 in it. And the other options are going to be two numbers that multiply to be 12. 2 and 6 and 3 and 4 are those options in this puzzle. 15 on its own could normally be 3 times 5 or 7 plus 8 in a puzzle that has 8 total. 1 to 8 is the range. 5 is already going to be over in the left here, so this is 8, 7 is an addition. We're now going to have in this 3 box a digit 1, and then either the 2, 6 or the 3, 4, whichever isn't used. 3, 4, and 1 don't have any version that gets them to 3, but 2, 6, and 1 can be a subtraction or a division, both of which equal 3. And so you can identify at the start of the puzzle that the top row is going to have 3, 4, 5 in the first 3 cells, 1, 2, 6 in the next 3 cells, and 8, 7 in the last 3 cells. And so that's a way to get started here. It's trickier to see, but you can do this exact same exclusion at the bottom, thinking carefully. The digits 1 through 8 add up to a total sum of 36, so that's the thing to keep in mind as we work through this. Right now we start with a sum of 13 in these 3 cages, so we have 23 left over. 18 could be a plus or a times. If it's a times, it must be 1, 3, and 6. There's no other multiplication set that will get us up to this. 1, 3, and 6 come up to another sum of 10, so we've used a total sum of 23. With 13 left over in this cage, and if 1, 3, 6 is over here, 6 plus 7 adding up to 13 can't work, and so the only thing left is 8 and 5, and 8 and 5, again, far too large as an overall group, don't have any values to get us to 6. Multiplication is unlikely to work out, and we've shown by just trying to place this triplet into these boxes, it doesn't work out. And it would seem most likely that getting these to add together, so we're pretty close to getting to a total sum of 36 is what has to happen, and that's correct. There are actually only a sum of 5 left for these 2 cells. That's a 1 and 4, 2 and 3. There's no way to get to 6 with 1 and 4, so this is 2 and 3, and a multiplication. And you might not think that these 2 digits are as critical to start the puzzle, actually be able to do a fair amount just from the 3, 4, 5 identification, but having these will really make it easy to break into this row, which is why I just wanted to focus on this TomTom type rule at the start, where we looked at this full row and this full row, which have cages everywhere, specifying their digits, and get to these kinds of exclusions. Another thing we can, I guess, claim at this point is that the 1 is in one of these 3 cells. Nothing else is quickly specified. I guess once we know the 1 is in these cells, the 6 is in one of these cells. But we're going to have a 7, 5, 8, 4 pair that's going to be alternating between the left or the right cages, and we'll have to do a little more in the puzzle to resolve that. The next fun part of the puzzle really has to be on this left side, and it's going to take advantage of all of these 2 cell 15s. 2 cell 15s, as we mentioned at the start, can be a 3 times a 5 or an 8 plus a 7. If we come back to this clue here, a 3 times 5 can't work in this cage, because if this digit is a 3 or if it is a 5, it's going to be touching that number in one of these kitty corner squares. So the very first deduction we can make of these 15 cages is a 7, 8. That now means that this cage which touches this cell touching both of these numbers can't be a 7 or an 8, so this has to be a 3, 5. This one below has to be a 7, 8. And these constraints together force this digit up here to be a 4. We'll now see that this upper leftmost cell is a 3 or a 5, which means that this cage as a group can't be 3 times 5. You'd be using too many digits too soon. Both of these would eliminate any option up there. We now have this cage which can look to be a multiplication 2 times 5, But this is where the 2, 3 we identified in the lower left is critical. If this is 2, 5, then in these 4 cells, we can only include a 2, 3, or 5, and we would not be able to fully fill this column. So this can't be a multiplication, it has to be an addition. 8 plus 2 and 7 plus 3 are already excluded because of values in the column, so 6 and 4 is what's left. We now get to wanting to complete this first column. There's a 1 in one of these cells. I can actually write something stronger here because the 3 is already going to be in one of the top or bottom. This cell left over is just a 1, 2, 5. If this is a 2, it makes this be a 2. So a 2 is excluded based on the no-touch rule because of how this pair, whatever this 2 sees, wherever it goes, it eliminates a 2 from there. If this is a 1, we now will have a hard time getting this 15 to work. 3 times 5 isn't an option. 8 plus 6 isn't an option, and there's nothing left over to get a high enough value for it. And so you can force out the 1 and the 2 from this cell, as we've shown, which puts a 1 up here, and exactly a 5 in this position, which forces this top pair, which forces this bottom pair. We can now try to complete this 15 with a 5 already in the cell. Multiplication is eliminated because the 3 is taken. So this is an addition with 8, 7 already used. 6, 4 is what's left over down here. Last digits are 1 and 2 in this column. 1 is touching that cell, so it's got to force it away. Once we place this 2, this digit has to be a 6 for multiplication for this cage. The 6 forces and pushes these digits around. This whole column now is left to just a 2 and a 1. This 2 here is going to force this digit in this way. And we get to here as sort of an early stall point for the puzzle, but very good progress in the leftmost columns. And we're now, you could think about trying to consider, these 5 cages, the 14, other things. They're not going to be very productive. What we've really done is set a wall right to this next column in column 4, where the digit options will eliminate a lot from adjacent cages. The 0 has a lot of options right now, but once we look at the 12, we're going to be able to resolve this pretty quickly. So let's start down here. 12 can start with some sums, 8 plus 4, 7 plus 5, but it's right next to a cage that has 8 and 7 taken, so the 8 and 7 are eliminated from these spots. Similarly, 6 and 6 here eliminates a 6 from these spots. So this isn't a plus, this is a times, and the times can't be 6 times 2. It has to be 4 times 3, and with a 4 already here, there's only one option at this moment for this cage based on this whole column being complete in the no-touch rules, which is the one we just filled in. We said at the start that this bottom group would have a 7, 5, or 8, 4 pair in it. The 4 forces now the 4, 8 pair over here, and 7 and 5 go into these cages. We can look at the presence of the digit 2 and say, where in this column can it go? It's not here, 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 or here. It's also not there, so 2 is in this cell. The 0 is going to have to be a subtraction, and the options you could see for yourself for it with the remaining digits, 7, 5, 2 could work, but a 7, 5 is down here, so the only thing that's actually available is 8, 6, 2 as a full group. This 6 eliminates the last option for this top cell, and it will suggest that a 5 and 7 go into this cell to complete out this group. The different set of things to think through from this point now will include how I think this 1 cage completes is going to be somewhat tricky. And I guess one way I want to get into thinking about that is to be looking at some positions that are available for larger numbers. There will be things we still have to fit into this now 5th column, having mostly placed the 4th column. And so different things to think about when doing that. Let me make this pair quicker to just see on the edges usefully. I guess the first place I am now looking is this 14. We had started where 2 times 7 was an option for it, but having just placed this 2, This limits this to be an addition with 8 and 6, which puts a 7, 8 here. The 7 that we just placed forces this. That forces this. Which forces this. For quick progress of that sort. The main thing some of this activity does is it places a lot of 8s in the grid. We'll see that we have an 8 in 3 different spots in these last 3 columns, which leaves just a spot, one of these two and one of these two for the very 8th 8 to be placed into the grid. And now we have an interesting thing, which is we have an 8 and a 1 cage, and there are only so many ways this can play out. And we'll want to think about other digits which can or cannot go into that space. For instance, think about if a 6 comes into the space, it's going to need to take a 1. Maybe a place to be looking is right here. We have 3, 4, 5 limit, 3, 4, 5 limit. Up in this cell, we also have a 3, 4, 5 limit based on things that are around it. The 3 in this cell would actually put an 8 or 2 below it, and those are both not options. So it looks like 4, 5 is what's going into this place. A 4 is going to only take a 1 to complete it out, and a 5 would also only take a 1, so I actually know that. That 1 removed now takes away a set of the options for this remaining set of digits, and I actually see right now that this is the only cell that can have a 3 in this whole column. So we're going to use that. This will take a 3, 5. Do a 1 here. It'll be a 4 in one of those spaces. So what other digits are required to be in this cage to get a total value of 1? This can be a minus or a division, but what it can't accept is all larger digits, 4 or above. A 2 has to get into this group, given that a 1's already in the column and a 3's already in the column. And so this deduction is one that we can write into the grid at this point. That doesn't actually tell us a full value for the cell yet, but it tells us it's a 4 or a 5. If it's a 4, it's a division. If it's a 5, it's a subtraction. Both the 4 and 5 eliminate as a whole the 5 option from the bottom. And with all this column now specified, we get the set of placements in the grid. The 1 here puts a 1 over there. The options for sums, 7, 7, 1 are no good. 8, 6, 1 is no good. This is a times. So we're going to need 1 and 3 with a 5. This 5 leaves one option for a 5 in the space. Forces this 4 finally. We have 1, 3, 5 left in this whole group. 3, as we've mentioned before, is going to need an 8 or a 2 in the other side of a 5 cage, and both of those are eliminated from what's in here, so this is really another 1, 5 spot. This row mostly complete, 7, 2 left over, so we'll just put actually those requirements in the grid. In the 6 column, I now see that 8, 6 is in these cells, so I have 1, 3, 5 left over. A 3 can't be here or here, so this is a 1, 5 group. 1, 5 eliminates the last option there. So these digits are just forced by elimination. This is forced by elimination. We're going to need to complete this space. 4 is the last spot it can go for this column. We need to get a 7. Well, we need to get a 1 down here. Has to be in this cell. I have 6, 7, 8 as remaining options. 6 is the only thing that works for this. Makes this be this 8, 7, 6, 8. This will be a 6. This will be a 7, 2. We now are left with using the touching digits to force the rest. So 7 pushes down, like so. And we get through this rather hard puzzle. I think it was a great example of using traditional TomTom, and then particularly examples like over here of the 15 cages using the no-touch rules as well, how the values in this cage set this no-touch, set this no-touch, set this, set this. Then we use no-touch in a tricky way in this corner to resolve all of these columns, and then we build over across. Like that this cage is an 8-7 by a no-touch constraint now limits 8-4 and 7-5 in the cell, and there isn't enough information otherwise in the puzzle to force these exclusions, but the solve kind of goes column by column at the start, which you don't see in a regular TomTom, but you could see in this TomTom no-touch. So hope you had some success getting through parts of the puzzle, and if you got stuck, hopefully this video gave you some tips for the future to get through this. We'll see you again soon.